Welcome to part 1 and the next lesson in our module on Android broadcast receivers. In this part of the lesson, we'll describe how to register, implement, and invoke broadcast receivers. There are several learning objectives in this part of the lesson. After completing this lesson, you'll know various ways that receivers can register to handle broadcast intents. You'll also understand how to implement the onReceive hook method. We'll discuss various concurrency implications of broadcast receivers throughout this part of the lesson. Finally, you'll be able to recognize the 3 types of Android intent broadcast mechanisms. We'll start by describing how to register broadcast receivers to handle intents. Receivers can register their interests in certain intents by using intent filters, as described in the earlier module on intents. The Activity Manager service is used under the hood to disseminate intents to the receivers that match the filtering criteria specified by the intent filters. There are 2 ways to register a receiver. One way is to statically register it by using the receiver tag in the Android manifest file. The other way is to dynamically register it by using various register receiver methods that are provided as part of the context. We'll first start by showing how to register receivers statically by using the receiver tag in Android manifest.xml. Here's an example from one of the phone app services that's part of Android. This is a receiver called Phone App Notification Broadcast Receiver. As you can see, it defines a number of different actions that it can handle in its intent filter. It can handle action hang up ongoing call, action callback from notification, and action send SMS from notification. The receiver of this intent that matches these intent filters will be started on demand if it's not already running. We can also register receivers dynamically by using various register receiver methods. Here's another example that's also part of the phone app. This example dynamically creates a phone app broadcast receiver, sets the appropriate intent filters, such as the action airplane mode change filter, and after all these filters are set, goes ahead and registers the receiver dynamically. Dynamically registered receivers must be hosted in a running app in order for the Activity Manager service to deliver intents to those receivers. By default, a registered receiver, whether it's registered statically or dynamically, runs in the user interface thread. A dynamically registered receiver can also be configured to run in a background thread. The way to do this is to pass a handler to the register receiver method that's associated with a looper. Here's a short example. It creates a new handler thread, starts the handler thread, gets the handler thread's looper, creates a new handler with the looper as a parameter, and then goes ahead and registers some receiver with various filters with that handler. In that case, the onReceive method that's called back on this handler receiver will be executed in the thread that's associated with the handler thread. Using this particular approach enables the use of calls that can't be performed in the user interface thread. For example, networking operations cannot be performed in the user interface thread. So by registering a broadcast receiver to handle the onReceive callback in a background thread, we can make various calls that access the network. A statically registered receiver can be configured to run in a different process. This is fairly straightforward and simply requires modifying one of the elements in a receiver tag in the Android manifest file. Here, as you can see, we're setting up this particular receiver, which is the Pong receiver, to run in a separate process called process 2. And so when it starts up, then the Activity Manager service will deliver the intent to that receiver and start the process if it's not already running. However, this configuration is rarely needed or used. Instead, a statically registered receiver is typically used to run in the process of the app that launches it. So by taking out that process element here, we can then have Pong receiver run in the same process where the ping receiver is running without having to change any of the source code. Let's now talk about how to implement the onReceive hook method. A receiver's on-receive hook method is intended to be very short-lived. By default, it runs in the user interface thread. An application not responding dialog is triggered by the underlying Android intents framework if a receiver hasn't finished executing its on-receive method within 10 seconds. Running in a background thread or in a separate process doesn't change these timeout semantics. A receiver is restricted in what it can do with an intent. For example, it can't register other receivers, it can't bind to a service, nor can it show a dialog. It can, however, do several things. A receiver can create status bar notifications. It can pop up toast messages. And it can also start other Android components, such as activities, services, or other broadcast receivers. For example, it's a common use case to have a broadcast receiver start a service after a system reboot in response to receiving the action boot completed intent. Note that a receiver is only valid for the duration of the on-receive callback by default. After on-receive method finishes and returns, Android considers the receiver to be finished, and it can then terminate the process it's hosted in if there aren't other components that are doing other useful work. If you don't want this behavior, then you can call the goAsync method, which is defined as part of the broadcast receiver interface. GoAsync can be used to keep the broadcast active even after returning from onReceive. What you typically do is have the onReceive method call goAsync and create some kind of background thread or interact with some other background thread in order to be able to do the computation in a background thread. Note that the computation must still complete within 10 seconds before the receiver's process is killed. When the computation that's running in the background is done, simply call the finish method on pending result to complete the operation. There are a number of uses of the goAsync method in Android's packaged apps. If you take a look at the code here, you can see nice examples. As a general rule of thumb, goAsync is used together with a handler thread or with a Java executor framework. We'll conclude this part of the lesson by giving an overview of Android intent broadcast mechanisms. There are three types of intent broadcast mechanisms supported by Android. The first type is called normal. These are sent by the context send broadcast method. Normal broadcasts are completely asynchronous. In other words, they don't block the caller. The Android Activity Manager service delivers normal broadcast intents to all receivers that match the intent filters concurrently and in no particular order. The second type of broadcast mechanism is called ordered, which are sent via the context send ordered broadcast method. These are delivered by the Android Activity Manager service to one receiver at a time in some order. The order can be determined by setting priorities. A receiver may also decide to cancel the broadcast so that no other receivers are notified. The third and final type of intent broadcast mechanism is called sticky broadcasts. These are sent by the context send sticky broadcast and send sticky ordered broadcast methods. A sticky broadcast remains available for receivers regardless of when it was posted. For example, if a late joining receiver comes along after a sticky intent has been set, it'll be able to be seen by that late joining receiver. Naturally, sticky broadcasts should only be used to inform apps about non-sensitive system state, since they stick around for a long time. It's never entirely clear who might be receiving them. This concludes part 1 of our lesson on registering, implementing, and invoking broadcast receivers.